We're going to start chatting about this compounds, alcohols, aldehydes, ketones, thiols, ethers. I'm going to skip the BS part and jump back immediately to the conversation about what these are. So basically, this is your first glance into what's called a functional group. Okay? So you can see that there are distinctive arrangements of atoms here and here, for instance, that change the properties of organic compounds. So let's say you take methane, okay, it's a bit annoying. Okay, you take methane and you replace one hydrogen with the OH group. So carbon hydrogen bond is non-polar. Stop acting up. Okay? Better. So it's a non-polar group. When you form a bond between carbon and oxygen, like this bond is polar because the electronegativity of oxygen is much greater than the electronegativity of carbon. Remember that story? And same is true for this bond, because the electronegativity of oxygen is greater than the electronegativity of hydrogen. So we've got a polar bond. And that completely changes the properties of the compound by addition of one oxygen atom. For instance, if you think about methane, it is a non-polar molecule. I'm sorry, I don't know what's going on here. Like, for real, I have no idea. There's some crazy stuff. Okay. When you start looking at methanol or phenol, they are strongly polar. Does that make sense? Methanol can be easily dissolved in water. Phenol, not that easily, but can also be dissolved in water. Okay? Other functional groups would include the ether group. This oxygen that connects two carbons is the first sign that it is ether that we're talking about. And this group that's called sometimes thiol, sometimes sulfhydryl. Okay? Does that make sense? Okay. So the functional groups that we learned so far, hydroxyl, thiol or sulfhydryl, and the ether group. Okay? You can see that in the ball and stick models, oxygen atoms are red, while the sulfur atom is represented by the green color. Any questions so far? So if you have a molecule that contains OH group, it is some kind of an alcohol. Okay? So how do you do that? How do you name them? You drop the E and you add OL when you name alcohols. So when you go from methane to methanol, you drop E at the end and add OL. Okay? Ethane, ethanol. If you have this, I hate when this. What is that? Butanol. So you write down, like you are about to write butane, but you don't write E at the end, you do butanol. Okay? Ethanol is the least toxic of all alcohols that we can get our hands on. Okay? So it is an intoxicating product. It is a drug. It is a poison. And it is formed by the fermentation of grains. I'm going to add some, that's one option. So we can take glucose or carbohydrates, ferment them, and produce ethanol. Alternatively, we can take ethene, and I'm going to expand this reaction if my software can cooperate with me. So think about this. This is ethene. Does that make sense? It reacts with water that I'm going to represent like this. So one hydrogen, this hydrogen, is going to interact with one carbon, and OH is going to interact with another. Am I making sense? So it's a hydration of ethene or ethylene. So you got the expanded structural formula like this. Does that make sense? You can produce the ethanol, industrially. The only problem it's usually not as it's not food grade. Okay? Now, before we get there, one thing. So you already named butanol for me, right? We've already discussed ethanol. You can imagine that there's a propanol, okay? And here's the thing. When humans produce alcoholic drinks, and I'm talking about strong liquors, well, not necessarily strong liquors. So let's say we have beer, wine, and strong liquors. To produce strong liquors, we distill them, right? One of the goals of distillation is to remove things like methanol, butanol, propanol, and other alcohols that are more toxic for humans. Does that make sense? Mm-hmm. It removes water and toxic stuff. Removing of water makes it stronger. Removing toxic stuff makes it less poisonous. The problem is that all the toxic stuff that is being removed is what gives a strong alcoholic drink often the aroma, very specific aroma, and a taste. So there's a technique in which you remove it and then add a little bit. Yeah, it makes it a little bit more poisonous. So here's the thing. If you look at all strong alcohols, the safest to drink, and I'm not encouraging alcoholism, trust me, but the safest to drink is vodka. Because ideally it's water and ethanol, period. Okay? Anything else will contain some other compounds, such as probably propanol, isopropanol, butanol in very small amounts, that will make it more toxic, like if people abuse it. Does that make sense?
So vodka is like the strongest?
It's not strongest. It's the cleanest. Less morning consequences compared to other things. Be careful. I did many of them. It is, trust me, especially in college. Few more alcohols, like for instance, this is glycerol. Okay, so it has 3 hydroxyl groups. Okay, what the heck? Pretty viscous. Anyone ever used glycerol? No? It's often a component of cosmetic products like shampoo, soaps, creams, that kind of stuff. So it is a very powerful skin softener. When I was a kid, I don't know how, I don't know where from, we always had a bottle of glycerol in the house. Probably my dad just took it from work. One of the best skin softeners ever. There's no smell, absolutely zero. It feels very weird when you apply it, when you have like really cracked skin, but it heals it in one application. You just have to walk around like not touching anything because it's pretty oily and viscous. But when it absorbs, it's great. Fantastic. Now, this one is glycerol is also sweet, but ethylene glycol is particularly dangerous. So it is sweet. I really like that statement. It is attractive to pets and children. I really want to see a cat who will deliberately open a canister of antifreeze, the car antifreeze, like it's going to be some pretty darn smart cat. Okay? Kids, yes, they will try everything, and it is very toxic. It is converted into, oh God, I forgot the name of the acid. So basically, OH groups are oxidized. I don't remember the name of the acid from top of my head. It's if somebody drinks ethylene glycol, it's converted into that damn acid. Huh? Thank you. Yes, oxalic acid. Yes, oxalic acid. It precipitates in kidneys, forms kidney stones, and it's a kidney damage. What's interesting is how the ethylene glycol poisoning is treated, as well as methanol poisoning. Anyone knows? So, a couple of things about toxicity. So, ethylene glycol is toxic. Methanol is also toxic. It's very toxic. And by taste, it's like Everclear, the same story. Like it's not pleasant to drink, but it will make person drunk, all the effects. The only problem is that 1 shot will make you blind, 2 or 3 shots will kill you. It's extremely toxic. Okay? So when people have methanol intoxication or ethylene glycol intoxication, the treatment is very unconventional. These people are being pumped with regular alcohol. Ethanol substitutes methanol or ethylene glycol in cells. It basically flushes it out of the system. Does that make sense? And what you end up with is not a person who's about to lose their kidneys, but the person who is extraordinarily drunk, has alcohol poisoning, which is way more treatable in a hospital settings. Does that make sense? I'm not making this shit up. It is a treatment. If you can do it on time, yeah. Okay? So this is another example of alcohol. It's basically made from phenols. This is a phenol. Okay? So this bisphenol A was added to a material used in production of plastic drinking ware, like bottles like this. And it was discovered that if you wash such a bottle, small amounts, very small amounts of bisphenol A, they will leak from the bottles into the water that you drink. What I don't like about the slide is like, okay, it leaks, and what's next? Turns out bisphenols, they interfere with certain endocrine functions in humans in very, very small amounts. And they can cause a long-lasting hormonal dysregulation. Now, the reason why they were added is to make the bottles antibacterial. So eventually companies stopped doing that. It should say that it's BPA free, bisphenol A free. That's fine. Not a huge deal. A lot of stuff that we add as antibacterial, antimicrobial, we don't really need it. There aren't too many microbes around at the end of the day. And some of the phenols, remember organic compounds? They produce the flavors and smells and some spices. Okay? Does that make sense? So, alcohols, anything that contains OH group. Okay? Thiols. Love that story. So they contain SH group, specifically, not just sulfur, SH group. I want to drivel a little bit about this. Strong and sometimes disagreeable odors. I mentioned before the compound, it's ethane thiol or ethyl mercaptane, this one. It is incredibly smelly. One of the smelliest chemicals in existence. Are you familiar with the measurement ppm, parts per million? If there is 1 part per million of that chemical in the air smells like shit, like very, very strong odor of feces. It's added to the gas, so we can sense it. And all sulfur organic compounds, whether they are thiols or anything else that contains sulfur, have this disagreeable smells. So when I was an undergraduate student, my bachelor's and master's were in chemistry, and I got pretty well used to the smells that we had in our building. There was one part of the building, there was a lab, they worked with sulfur organic compounds like thiols. Even for us, it was sometimes too strong. Those people who worked in that lab, that is not an exaggeration. If they would walk out of the lab in their lab clothing, go into the subway, get in the car, the homeless folks would leave. In order to get the smell out of the hair, you shave your head. They had a set of clothing to work, like they come to work strip to the undies, put new clothing, work, strip to the undies, go home. It is very intense, extremely intense, and very unpleasant. The reason why you cry when you clean onions, sulfur organics. The reason why garlic has such a distinctive smell, sulfur organics. And this is why, by the way, it has also some antibacterial properties. Cheese, not every cheese, but the smelliest ones, oh yeah, that's sulfur organic included. Okay? So naming is fairly straightforward. You get a hydrocarbon, okay, and add thiol to it. So methanol, methane, thiol, ethane, thiol. Just like with double bonds and hydroxyl groups, you want the number of the functional group be the lowest. Does that make sense? So if you look at this molecule here, there are essentially two ways to number it. 1, 2, 3, and 4. Agreed? Or, alternatively, you can do 1, 2, 3, and 4, but you want the lowest number for the thiol group, so it's going to be 2-butane thiol. Okay, so far makes sense? So, ethers. They contain oxygen atom that connects to carbons. Okay? Now, these carbons can belong to hydrocarbon chains, you know, like this CH3, or I can come up with this. Okay, so this will be diethyl ether. Does that make sense? Two ethyl groups. Okay. If you have two different substituents, for example, you have a molecule that looks like this, okay, so it will be ethyl, methyl, ether, right? Because this is ethyl and this is methyl. Am I making sense so far? Okay, good. Here's another example of methyl propyl ethers. What I want to highlight, and it's something that you must know. So alkyl or aromatic group that is attached to oxygen, and they're written in alphabetical order. So if you go up here, I named this molecule ethyl methyl because ethyl comes first alphabetically. When you go here, it's methyl propyl because methyl comes first alphabetically. Does that make sense? So ethers were used as anesthetics starting in, I want to say, like 1850s, 1860s. I think they were used after, like, wide usage was even after the Civil War in the United States. So it will be like late 1860s. Which is bananas, if you think about that. If somebody gets the surgery in, I don't know, 1812, American-British War, what do they use as anesthetic? How do they secure a patient? Bottle of whiskey and a couple of really strong men. You're still going to feel the pain, yeah. You're just going to be like, people will hold you while the surgery is being performed. Plus, you're getting drugged by alcohol. Okay? So, ether anesthesia is now not particularly common. Okay? It wasn't used for hundreds of years. It was used for about 100 of years. Okay? The problem was with ether, especially this one, it is insanely flammable. Okay? I believe that the flammability point is under 100 degrees Celsius. So it could explode. It was very substantial fire hazard, which is not a great thing to have during surgery. So eventually they were replaced by these chemicals, which we also don't use a lot anymore. We use, for the most part, nitrous oxide, N2O, the laughing gas. But you can see that hydrogens in these molecules are replaced with either fluorine or chlorine atoms. That makes sense? This makes them indeed less volatile, and it makes them non-flammable. The only problem with isoflurane, I worked with it, the anesthesia doesn't last long. I'm going to digress a little bit and give you some context because we are definitely ahead of the schedule with this, so we're doing good. Isoflurane is actively used in veterinary medicine to anesthetize animals. And my wife used it when she worked with animals that had to be anesthetized for a long time, like mice had to be put to sleep for a long time. They had a machine, special machine that was like $10,000 or $15,000 just to provide consistent anesthesia to mice. I had to anesthetize mice as well, but for a very short period of time. I needed to give them nasal drops. And anesthesia was very simple. I had a Tupperware box with a piece of gauze soaked in isoflurane, closed. When I needed to anesthetize a mouse, put it in the box, close the lid, wait for 5 seconds, open the lid, the mouse is asleep, I do the drops, praying that it doesn't wake up, because it doesn't last long. It's not a long-lasting, like, really, I do the nasal drops, I put it on a bench, and 15 seconds later, it's just like drunk mouse walking around, you put it back in the cage. It's fine. It goes away very fast. So this is why it's not convenient to work with. It's really hard to calculate the dosage, so not particularly great one. Okay, the properties. So there are two things, well, several classifications. This one is very important. Primary, secondary, and tertiary alcohol. So what makes an alcohol primary, secondary, or tertiary? Basically, number of carbons that are attached to the carbon that is bonded to oxygen. Okay? So, I'm going to illustrate it This is hydroxyl group with the oxygen. You follow? This is the carbon that is bonded to oxygen. You follow? This is the only methyl alkyl group, another carbon, that is bonded to this one. This is why it is primary alcohol. Do you follow? This carbon is connected to oxygen and also is connected to two other carbons. Two, not one. It is a secondary alcohol. Okay? And in this case, this carbon that's connected, bonded to hydroxyl group is also bonded to 1, 2, 3 other carbons, which makes it tertiary alcohol. I can guarantee you that you will have to identify primary, secondary, or tertiary alcohol on the exam. 100%. So, let's classify them. A, primary, secondary, or tertiary. Let's do the analysis on the first one, okay? Oxygen, everybody agrees with it? This is the carbon that's bound to oxygen. How many more carbons is this one bound to? So, secondary. Agreed? Primary. Very good. And the bottom one? Tertiary, because this is the carbon of interest which is bound to 1, 2, and 3. Tertiary. Solubility. Alcohols are kind of weird molecules because OH group is very polar. Okay? You can see it right here, and you can see that oxygen has a partially negative charge, while hydrogen has a partially positive charge, because oxygen's electronegativity is greater than the electronegativity of hydrogen. Am I making sense? All good? If you look at the molecule of water, I talked about it. It is polar, with oxygen having slightly negative charge and hydrogens having slightly positive charge. So therefore, OH group in the alcohol can form hydrogen bonds with molecules of water. Does that make sense to everybody? So these are hydrogen bonds. Is it clear? Yes, no, maybe? I'm not sure. Good? Okay. Now, this part of the alcohol molecule is obviously polar. However, if you look at these bonds, the bonds between carbon and hydrogen are considered to be non-polar. Am I making sense? So, remember, electronegativity for carbon is 2.4, I believe, and for hydrogen is 2.1. So the difference between them is too small to make this bond polar. Therefore, this part of the molecule does not have any polar bonds. Understand? So the bigger the carbohydrate, the hydrocarbon tail, the less soluble the molecule is. You can kind of think about this using the illustration like, so for instance, let's say OH group is red circle. Okay? And the hydrocarbon tail is blue circle. Okay? So remember, hydrocarbon tail is not polar. So if you look at ethanol, which is right here, it has a modest hydrocarbon tail, and it has an OH group. Sounds good? If you look at octanol, the bottom one, 8 carbons, right? The size of the OH group, the polar one, remains the same, but the impact of the hydrocarbon tail is much more significant, so the non-polar properties take over. Does that make sense to you? So basically, one to 3 carbons, these alcohols will be soluble in water. Methanol, ethanol, and propanol. Butanol, slightly soluble. Okay? Pentanol, already insoluble. So, hand sanitizers use either ethanol or isopropanol. So I'm going to put some formulas in there. Ethanol, you already know what it is. Isopropanol is this. Okay, isopropanol, or sometimes it's called 2-propanol because the OH group is located at the second carbon. We don't use methanol. Remember I was talking about like methanol, this one? We don't use it because of its toxicity. Somebody might ask, wait, but it's hand sanitizers, right? We put it on the hands. We don't drink it. Well, you don't. If people in general see that the product contains alcohol, people have a tendency to use it as a recreational drug. If it's methanol, they're going to die. If it's ethanol, they're not going to die if they don't use too much. What if it's isopropanol-based hand sanitizer? Isopropanol will be converted to acetone, and people will have very nasty poisoning. They're probably not going to die, but that's going to be pretty bad. Okay? So it's going to teach them. So now I'm going to turn on slightly different regimen, which is a microbiology teacher regimen. Okay. It's not an alternative to washing hands. It is not. It complements hand washing. They do kill most bacteria, they kill some viruses. They do not kill the viruses that cause cold. Just not. I can't explain why, but not. And now, none of the hand sanitizers contain triclosan because FDA officially recommended to stop using triclosan. It was about 2018 because it was not particularly efficient. Okay? Let's see. Okay, we're going to talk about phenols and we're going to stop at that. It's perfect. So, phenols, this is a typical phenol. Slightly soluble in water, okay? And they will react with the water making it slightly acidic, okay? They were used as antiseptics. Two words, carbolic acid. Does it tell you something? Sounds familiar? No? Maybe? It's a solution of phenol in water. Very strong irritant. Pretty good antiseptic. Destroys tissues along with bacteria. Was the very first antiseptic agent ever used. It was used by Joseph Lister in 1860s. Okay? What I find fascinating about phenols, again, I told you they're very strong irritants. They solid at room temperature. But the melting temperature is about 35, 34 degrees Celsius. I don't remember from the top of my head. The point is, if you put a piece of phenol between your fingers, it will start melting. Guess what I did? Third year of college, or chem, when we learned phenols, and I learned that they are very strong irritants. I grabbed a piece of phenol and held it between the fingers to see what's going to happen. And I got a chemical burn. It wasn't something like terrible, but it was a visible chemical burn because it was melting in my fingers and just, destroyed my skin. Okay? That makes sense? Okay. We're going to stop here.